Hi everyone, this is James from the Freemasons again, and welcome to the second tutorial on parallel processing. And this time, as you can see, we're in Apple's flagship application, audio application, Logic. Everything I'm going to show you here is completely doable within Logic X. We've just not switched over to X at the studio just at the moment. So look, what we're going to show you is a method using parallel processing to turn quite lifeless and otherwise fairly normal sounds like this drum loop into bigger, better and beefier sounds like this. Okay, so look, I'm just going to start completely from scratch again and start with our basic drum loop. Now, as you heard there, it's a nice thing. It's obviously from a very famous Rihanna song, and it is an Apple loop that comes with Logic Audio. It's called Vintage Funk Kit 4. Just play through again. Now, it's nice enough, but as you can hear, it needs some EQ. It needs some work to bring out the tops, bring out the bottoms, a little bit of the mid, and probably some compression as well. So, standard way of doing this, and I'm only going to use Logic's built-in effects for all of this, so everyone can do this. We might want to raise the top a little bit. A great trick with Logic's channel EQ is if you bring the Q value all the way down here, you can really kind of almost tilt EQ from quite a long way up, and you see it just brings a general curve up like that. But even on quite normal EQs, it can sound quite brittle, and it can sound a bit just not very pleasant, and we can do a better job than that using parallel processing. So very simply, what is parallel processing? Well, it's having the same set of audio go to different processes instead of the processes coming down as we would do here with in a linear fashion, in other words, or a serial fashion from the top, the first effect down to the second one. We're just going to duplicate the audio and apply the EQ to a second channel that's kind of next to it effectively. And this is why it's called parallel. So you have the original untouched source material, and you have your EQ'd version here. And I'm going to go even more severe. Now, that's not an EQ you'd like to hear completely by itself, but look what happens when I start to feed it in on top of the original. Maybe a touch too much there. Take the very top off. So before and after. And that is a much better way to kind of get the same kind of EQ curve that you want, but still keep the original feel of the material. Now, the reason I go to the top first is that your brain works in specific ways when it comes to sound, with location and presence, and the brightness of a sound dictates how close it kind of is. So on a principal sound like this that's probably going to be quite forward, you probably want to do the top first. The reason being is if you EQ'd the bottom, you're not going to make the right judgment call. It will start to get woolly very, very quickly, where our ears tend to prefer things to get brighter first. So now I've done the top, I'm just going to literally make another copy, take that EQ out, or just do another one, and I'm going to quickly go around the 90 Hertz region to really pick out some of the kick drums. Now, that's again not the kind of EQ that you'd actually really like to hear on your loop as a whole, but watch what happens again when I start to feed it in. You get that extra weight added in, but we're still with the integrity of the original caps. Now, the one thing I'm going to do here is I'm just going to drop, I've just selected all of the faders, I'm going to drop them all down a little bit. There's a very good reason for that. Parallel processing is a cumulative effect, so you're adding more and more signal to the original source, which means it's going to get louder, so you just have to keep everything under control. Okay, now the next one I'm going to do, and you'll notice I'm using this button here on the top left just above the track list. It's a great button, and you'll see why we use it in a little moment, but it basically creates a perfect copy of the track that you've got selected directly underneath it, and that's perfect for this kind of thing where you're just kind of wanting to layer stuff up. Now, parallel processing most common use has always been with compression, and I'm not going to use anything flash. I'm just going to use Logic's built-in compressor, and we're really going to go to town. And let me show you why parallel compression was one of the is one of the most used and popular versions of parallel techniques. So I'm going to hit the ratio all the way up, and I'm going to flip open this button. Now, a lot of you know this is here, but there may still be a few of you that don't know that this exists. This is amazing. It allows you to basically clip the output of the compressor in the same way that certain bits of hardware might react. And it allows you to do some quite crazy things. I'll show you in a minute. So we just got that on soft clip at the moment. Let's put the drum loop through it. And I'm going to dig into it dramatically. Ratio right up, attack right down. Don't really need the transients. And what I'm looking for is weight from all the sustains of the drums and the kind of room sound behind. Okay, now the next thing, now I've got the output distortion on, I'm going to actually push the gain of the compressor out. And you'll see that it levels out. It just literally hits the ceiling and won't come. That's because of that output distortion, but it allows us to really drive the sound of this compressor. Now, once again, that's far too compressed for how you may like it, or some of you may like it like that, but look what happens when I feed some of this compressed signal back into our already interesting. Not much ambience, not much power really on the actual individual drums. Now, brilliant. It instantly sounds like a 70s breakbeat. Now, the great thing about doing this kind of thing, you've probably heard this sound on a lot of contemporary records, especially the kind of new neo-soul ones that are referencing Motown sounds and that kind of thing. This technique has been used by a lot of very big mix engineers for a very long time, especially the ones in New York, which is why it's often called New York compression. So I've just done something quickly there. Let me just show you now how we can take that compressor setting, completely duplicate it, just by hitting that button there. Exactly the same copy, and now I can dig in even further. And on this one, I'm going to use one of the VCA emulations, which emulate some of the old vintage desks. You'll need a little bit more compression, but we'll say, well, once again, we're really going to go to town on this. A bit less of that. And we found this switch is particularly useful. Okay, now we've got some pretty heavy distortion. Now once again, that may not be a sound that you'd really like your entire loop to sound like, but look what happens once we start to feed it in. So if I just quickly group all of these together, and we'll do a before and after. So this is our drum loop. It's got groove, but it's not sounding great. Now look what happens when we add in all of the parallels we've just added. I'm just going to turn off the group functionality there. The beauty of this is, now we're using a drum loop here, but say you had a vocal and you were doing the same thing, because vocals work beautifully like this. And say there was just one line where the singer might have come off mic, or it's just not cutting through on a dense or busy mix. If you had this level of control and you left it open on a vocal channel or a vocal stem, you could just for one moment automate the top end slightly. To just for that moment give it a little bit more zizz. Now I'll probably do a demonstration of that properly later on, so let's just rename what we've got. Top, bass, crush, and pretty much destroy. And there we go. Now this is one method of doing parallel processing within Logic. I'm going to show you another one with a synth part, and there is quite a good reason why we use the second method, particularly if we've got VSTs playing live that we don't want to bounce down into audio. The one thing I do find though is running in audio within Logic is a beautiful experience and sometimes the best. So what I'm going to do, because I'm happy with the way that that loop sounds, I'm going to make a decision, and I've got B set up on my keyboard, shortcuts, to actually bring up the bounce in place functionality. So we've got, this is very important, you have include volume and automation, otherwise it'll just level all the faders at 0 and do it. And just keep the tails there just in case there's anything. Keep that one off, obviously, otherwise you're just going to bypass all of these effects. We're going to delete the original and we'll just call this Funk Kit 4 Slammed. That's one of the beauties of Logic. Now I've made a decision, I'm happy with the sound of it, and I've just got rid of all of the processing, and now I have a huge sounding drum loop compared to where it started from. Okay, so this time I'm going to show you parallel processing using buses and the auxiliary system within Logic Audio. Now I'm just going to show you why you would use this first of all. So instead of a drum loop, which was static and a piece of audio, we've got a little MIDI part up here that's playing on a synth called Oxium. That's made by IXLS Labs, and there's a very good reason why I'm using it, because this is a very good analog emulation, and it will kind of drift a little bit on its oscillators. So this is it just by itself, just one, this one here. And what I've done here is just emulated the kind of processing that we did on that same drum loop, so you can hear a similar effect. But this is why we don't use multiple versions of synths to do this kind of process. If I just open these up, you'll hear, even though the processing's there, it's kind of gone very phasey and a little bit odd, and it's changing on each note, and it's that horrible sound of kind of different versions of the same synth playing together. And what's happening is, because Oxium is drifting slightly, it's deliberately making it sound analog, so not every voice is the same. All these different instances of Oxium are playing the notes just slightly out of tune with each other. So when you apply the processing, you're not applying the processing properly in parallel. It's, each one is its own individual animal to a certain degree. So you're getting that kind of weird thing. So look, what I'm going to do is strip all those other versions out and show you this next method very quickly. So this is our original sound. And what I'm going to do is route the entire output to a bus. And we're in a very simple page here, so it just comes straight up. So let's just call this vanilla. And we're going to call this auxiliary dry. You notice I'm naming it at the bottom. It's not available on the audio page at the moment. We don't really need it either. So that's fine. All that's happening is the synth is being routed to bus 1. Bus 1 is being picked up on an auxiliary and being fed to the stereo output. So that's great. So how do we do the parallels? Well, it's dead simple. If you go in the mixer window to the options function here, you have a little, it will bring up a dialog box to create new auxiliary channel strips. And what that will do will allow you to, let's have 5 of them, for example, and we're going to obviously make them stereo. We're going to take that ascending checkbox off. I'll tell you what that does in a minute. And we're going to select bus 1. So this is now going to create 5 new auxiliary channel strips, all going, all in stereo, all being picked up or having their source set to bus 1 and then all going to the stereo output. Now, if I clicked the ascending checkbox, the first out of the 5 being created would be bus 1, the second would be bus 2, bus 3, etc., etc. We don't want that. We want them all to be the same. So I'm going to create them. Now I'm going to pull the faders down, but look at what's happening now when I play back. We have 5 new versions of exactly that sound, so we're not worrying about oscillator drifting or anything like that. It's all coming back exactly as it is, and this is when we can start to apply the parallel processing. So solo the first one. As we did before on the drum loop, I'm going to dramatically lift to get some bite, and I'm even going to take some really that crunchy mid-range. And we've got it in solo at the moment. We'll call this top. It's not particularly very toppy, but let me show you what happens now. So original, and same again, we feed it in gently. Now, quite severe EQ there. You wouldn't want your sound to ever sound like that by itself, but together. Okay, so let's do as we did before. Bass on this one. Let's find a nice little sweet spot. It's going to be a bit honky, this one, but we'll give it a go. Just take some of the mud out of there. Okay, so add this in gently. And you instantly hear the sound start to rebalance itself between its treble and mid-range parts there. Now, this kind of sound just eats up compression and distortion. So with this one, I'm just going to name this one Top quickly. Let's get some compressors on the go for this one. Soloed our next blank channel, or our next blank auxiliary. In fact, let's go VCA. If you bring the knee down, the compressor can be much more severe. And once again, we're going to use our clipping function. Let's push into it. Bring some of that in. Now, sounds like this just actually eat up a delay. So on the second one here, I'm going to set a delay. This is all still in parallel, bear in mind. And you notice I've left the first one free. That's because I'm just going to click an EQ to EQ into the delay. I'll find a nice tasty spot for the delay. And I don't know if any of you have tried this, but sometimes automating sweeps through delays is a brilliant thing to do. Now I'm just going to add some compression to this particular channel. Sorry, wrong one. Add some compression to this as well. Let's clip our output again, why not? Okay, let's feed some of that delay in. And I'm also going to, on the fifth channel, add the beginnings of some pretty, in fact, let's use the Bit Crusher. I've got a great little setting for this. 10-bit seems to just add just a hint of noise, makes it sound a little bit vintage, and you can nicely gain into it. And then so let me just show you where we were. This is our original sound. And that's what all the parallels are doing. Brilliant. Now, you might wonder why we're kind of doing this. It does seem a bit of a laborious process, and it is to a certain degree, but it just really allows you to set up a series of processing that you're just never going to get using simple dry and wet functions. What I find with, as you go down in a serial manner and start to add effects like delays, every time you move a dry or wet slider away from dry into having more process, you instantly lose level, and your brain does something weird. It doesn't kind of compute. It feels like you're losing something. Whereas with this, you always feel that you're adding with something. You do have to watch your levels, obviously, but it's sometimes much more of a psychologically rewarding system. Now, say you've got that and you really liked it, and you just actually wanted to render that down and make a decision to keep it. You do have to be careful if you've got stuff on the master fader, because the traditional method would be to hit this bounce button here and use the standard dialogue to bounce out to wherever you'd like to in your file system, and then actually pick it back up. We find that can be a bit messy whilst you're working, so what we tend to do is just let's pick a sort of very high number. I always try, for some reason, always go for 41. So I'm creating a new channel with a blank bus input, and then I'm going to route all of our processed versions and the original version, the kind of untouched ones that are all living on buses, and route them to that output. So It looks complicated, but I hope you kind of gathered what I did there. I've just routed all of the outputs of the dry channel and these newly affected parallels all out to the same bus, and I've created a new channel with picking that bus up. So you're completely using Logic's internal routing system, and then we'll call this Oxium plus parallel. And now I can just arm the track and hit record as normal. And our newly bounced version is there, so we can actually now simply, if I just turn this back to stereo, I can show you before and after perfectly. That's how we started, and this is where we've ended up. Brilliant. Now, as I say, the reason we've done this in this manner with this sound is that we have a live instrument that is very good at emulating vintage synth. So it sounds great, but it will drift in between every single note. And each instance of that will be kind of slightly random as well. So you're just going to get some, if you tried to just use the method we used before, it's just going to get messy. Doing it this way is great. And then also, if you think about it, once you've created a series of buses like that, they're there for you across the entire session that you're working on to use on other sounds. And sometimes just having things when working on them quite randomly, I don't know why I called that on top, let's call that bottom. There was a very famous mix engineer who used to walk into a studio that was used by someone else the day before, and he would specifically ask the assistant engineer never to reset any of the EQ settings, because he said he just liked to throw things up, and every now and again he would put the tapes up and throw it up on a channel that had an EQ setting from the day before from someone else's mix, and it would just work. So sometimes just going through your sounds and maybe trying them, if something's not working, just try throwing them into a set of buses like this that you've got set up for something else, and just see if they work. Okay, so that's it for Logic. The next one we'll do is to show you how this is done in Reason, which is a very, very elegant solution. And then we'll do some kind of quite over-the-top versions of this type of processing and show you how beautifully it works on vocals.